Alright guys, so after so long I'm back to this YouTube channel, and there are a lot of reasons and a lot of non-significant reasons to not come here. But before that, let's get started with the problem. So our next problem is median of two sorted arrays. If you want to see further three solutions, you can check out the description. I'll post the link there. Here's the statement. We are given two sorted arrays, nums1 and nums2 of size m and n. We have to return the median of two sorted arrays. Alright. Follow up is this. The overall time complexity should be this. Running time complexity. Okay. So what we have here is we're given two arrays. We have to return the mean, and simply the mean of these three elements is this. We merge them, we get this. Median is this. Next case is that we have this array. The median should be mean of 2 and 3, so 2.5 that is. Alright, an explanation is also given. Next case is this. Simply median will be 0 only. Here median will be 1 only. Only one element is there, so 1 will be the median. And here 2 will be the median. Alright, so we have this here. Okay, let's come to the approaches. First approach I have is, suppose we have an array, this one, okay, and second one this. The idea I have is that I can just take this array, okay, append it to the end of first array, okay, I'll get a whole big array. I will sort this and then I'll get the median, the central element or elements, take the mean and return its value. It is a simple brute force solution which has complexity of n log n or order of n log n, because we are sorting an array and sorting is of order n log n simply, and we are given the condition that the complexity, running time complexity of this solution should be just logarithmic, not linear multiplied to logarithmic, so it won't work. The next approach we can have is we can simply merge these two arrays because these two are sorted. So when we write the sorting algorithm merge sort, we can just have elements. Okay, so suppose we have element 1, 2, okay, 3, 4, okay, and then 5 and then 6. Suppose we have these two sorted arrays, all right, and I want them to be appended with complexity, linear complexity. Okay, so in merge sort what we do, we use two pointer approach here. Okay, so I is pointing to this element and j is pointing to this element. Now what I'll do, I'll compare element at I and j, which one is smaller will be inserted to this final concatenated array. So 1 will be here. Now because I inserted this, so it will move ahead. Now again I'll just compare 2 with 3, so again 2 will be inserted. Then again I will point to this, okay, then I'll compare these two elements. This time 3 will be inserted here, then it will move ahead. Again 4 or 5, so 4 will be there, then because 4 is inserted, so 4 pointer to 4 will be moving ahead. Now comparing these two, so 5 will be inserted and then it will move ahead, and that to the end of this array. And simply in merge sort we understand that when any of array just finishes, like in this case I just get out of this array, then we just simply paste the entire remaining other array to this. So 6 will be here, and this way I traversed linearly and I got sorted array. I hope this makes sense to you. Or if I just summarize it again, then I'll have two pointer approach here. I will compare elements, insert the smaller one, and that particular pointer from where I took the value to append, that pointer will move ahead. Okay, until we have both the arrays, we will keep on comparing and inserting, and as any of the array finishes, second array will be inserted as it is. Okay, now after this I will just find the central element and take the mean if there are two and return the value. So that will be my median. Okay, now here I see I did linear work. All right, so it will have complexity order of m plus n. Okay, but again we are clearly said that the overall runtime complexity should be order of log m plus n. So this won't work again. So more optimized solution is here. All right, so here the optimized solution will be like this. I will just assume that elements in first array are some elements on lane 1. Okay, lane 1 in road, and elements of second array are on lane 2 of the same road. Okay, now I do understand that median is like the center of this entire array. All right, that is the main idea with median. So what I will do, I will find a proper location. Like in this case, I know that up to 3 elements will be in the left half, and after this will be in the right half. So I will make some wall like this. All right, so I will find some proper place to make a wall. Okay, and corresponding to that I will make another wall in this lane. All right, and then I will get left group of elements like 1 2 3 here, and right group of elements 4 5 6 here. Okay, now this is the algorithm, just try to understand. This is the example taken for that. Now I got left half of it, okay, and right half of it. Now if total elements in these two arrays are even in number, this means I will have two median elements. Like in 10 I have 5 and 6, like in 12 I have 6 and 7. Okay, so if even, then I'll have two median elements. But if there are odd number of elements in these two arrays, then I'll have only one median, and that too will be the maximum of biggest elements of left group. Okay, listen it again. If there are odd number of elements, then the median will be maximum of these two elements. All right, why maximum of these two? Because these two are the center of it, and which will be more closer to center when sorted. When I'll be combining these two, these elements will be closest to the center. Okay, and these two for sure. So if I take maximum of these two, that will be more closer to center, because all these elements in left are smaller than all these elements in right. So if these are half of elements, then maximum of these two groups, or I can say this entire left group, the maximum of this will be the median. If there are odd number of elements, but if there are even number of elements, then maximum of these two, okay, maximum of these two and minimum of these two will be taken. So like 4 here, okay, and 3 here. So what I'll do, 3 plus 4 over 2. So this way I'll get the median, okay, because I will take maximum of left group, minimum of right group, and because if there are even number of elements, so I'll take the median, not sure median, I'll take mean of these two, and it will be, so it will be 3.5. This way I'll get the median. And here the question is now that I am to find the proper place for this wall. Okay, if I'll get this proper placed wall, then I'll get corresponding wall here, and then I will check if even number of elements, then I'll take maximum of these two, minimum of these two, and take the mean and return it. If there are odd number of elements, then maximum of these two and return that. Simple. So the case is to find this place where I'll insert the wall. Okay, so because this is a sorted array, so I will simply do binary search for a proper place where I'll just check the case. Yes, is it the center, with the condition that this has to be greater than this and this has to be smaller than this. This means this is not smaller than this and this is not greater than this. Okay, then I can say that my wall is at proper place. So here's the idea. I will firstly get the proper place for wall by doing a binary search. Okay, I'll compare these two elements, and one on the right half should be greater than one on the left half. Also I'll compare these two, one on the left half should be smaller than one on the right half, less than or equal to, again same way here. Okay, and then I will just check if there are even number of elements, then one from left, one from right, and mean of 2. If there are odd number of elements, then maximum of left, return that simply. Done. Okay, now let's code this. Because it is a binary search, so it will be of order log m plus n, because ultimately we can say that we will be just considering this whole group, so it will be of logarithmic by order. Okay, so let's solve this. So here we have this, we are given what I will do, I will have the size of these two first. Okay, so int m equals to nums1 dot size. Okay, int n equals to nums2 dot size. I got these two. Now I will just ensure that m, or I can say nums1, is holding the smaller array. So if m is less than n, then that's all right. If m is greater than n, then I have to swap these two. Okay, so then I will just create a vector of integer t. Okay, t equals to nums1, nums1 equals to nums2, and then nums2 equals to t. Okay, this way I swapped these two vectors if m was greater than n. I also have to swap the values of m and n, so there is XOR, but still int tmp tmp equals to m, m equals to n, n equals to tmp. All right, so this way I swapped these two arrays. I am to do a binary search, so I have int l, that is for low, 0, and h, that is high, and that is m. All right, now I am to do a binary search, so while l is less than equals to h, int I is there. Okay, I will be the place pointing to this position. Okay, I minus will be left of wall and I will be right of wall, and because elements in left group are greater than equals to, just one greater than or exactly equals to elements in right group, so what I'll do, I will just get j as half of this entire number of elements minus I. Okay, so I'll get I equals to L plus H by 2, j, okay, j is to be declared again, j equals to, okay, half length is also there, so half length is equal to, I understand that if total elements are even, then m plus n by 2 will work, but if there are odd, then it will work. Okay, and it will neither affect the case for even elements nor for odd elements, or simply if you want to find the median of an array, then this is the index for a sorted array. Okay, so this is half length. Now hl minus I will get me the place for this j. J is here, all right, and j minus 1 will be here, so I'll get these two. Okay, now I will check if this is the right place for my wall. So if I is less than the highest of its value, okay, this means I can move ahead, and I need to be increased. This means this element is smaller than this element, then there will be problem. Okay, if this element is smaller than this element, if a I is smaller than b j minus 1, if that is the case, this means I need to be increased, so L equals to I plus 1, as we do in binary search simply. Okay, and if that's not the case, else if another case is that j should be increased, or I can say I should be decreased. So if I is greater than L, okay, and it need to be decreased, this means this is greater than this. Okay, if this is greater than this means I need to be shifted leftwards. So if a I minus 1 is greater than b j, then I can say that I need to shift to left. Okay, so h will be I minus 1. Okay, this is the second case. If I need to shift to the right, then this will run. If I need to shift to the left, then this will run. Otherwise, sorry, this is our final case. Okay, if we got right place for wall like this. Okay, now what I'll do, I'll calculate leftmost element. Okay, now I will find if I got this right place for wall, then I'll check the maximum of left group. Okay, okay, if there is the case of even or odd, I know that maximum of left group is to be calculated. That is mandatory. Okay, so let's do that. So finding maximum of left, okay, that is 0, or I need not to just initialize it, but that's all right. Now what I will check, just understand the edge case first. Okay, if my wall is at the center, then it's totally good. I will just put this, what, mxl equals to maximum of what, a I minus 1 and b j minus 1. Okay, so maximum of a I minus 1 and b j minus 1. All right, we got maximum of these two, but this is not the best case, so we have to consider other two cases as well. So there are edge cases. Suppose this wall is here. Okay, suppose this wall is here. This means I is pointing to first element and I minus 1 even do not exist. Then what I will be doing is, if I is 0, then I know that I minus 1 won't be the largest element in left group, so maximum of L equals to b j minus 1. All right, because I minus 1 index element do not exist, so this has to be the biggest one. Okay, else if this is the case, suppose this time wall is not here but here. Okay, if wall is here, then I can say that j minus 1 cannot contribute to maximum of left, because b j minus 1 cannot contribute to maximum of left. So if j is equals to 0, then b j minus 1 cannot contribute, so mxl equals to a I minus 1. Okay, so let's try to understand. We just consider the case that wall is here, so b j minus 1 has to be the maximum of left, or if wall is here, then a I minus 1 has to be the maximum of left. Okay, if there is no any edge case, then I will simply get the maximum of ai minus 1 and bj minus 1, and I'll get this. Okay, now I do understand that I have calculated maximum of left. Okay, so if m plus n is odd, so if this whole, if this is odd, okay, this is simply bit manipulation. I can also say that this mod 2 is equals to 1. Okay, so if that is odd, then return mxl. I hope this makes sense. We are just taking the case that it is of odd length and we have to return only one median. Okay, and simply one, that means without taking the mean. Okay, and that will be maximum of these two or end cases. Okay, that's simply, so we will just return that. Okay, but if that's not the case, then I have to calculate minimum of right. Okay, that can be initialized with 0 simply. Now if, again dealing with the edge cases, so suppose there is wall here. Okay, so I know that I minus 1 will be at this last element and I will be at m. You might be thinking that this is the last element. What do you mean by m? See, last element of this array lies at index m minus 1. Okay, and I will be at m in that case. Okay, so if I is equals to m, then just, okay, if wall is at the end, then I can say that minimum of right can't be contributed by this array. Okay, first array can't contribute to this, so a j will be my minimum of right. So minimum of right will be a j. All right, else if, now suppose wall is here. Okay, if wall is here, this means j is equals to n, and this means that minimum of right is equals to b j, not bj. If this is the case, then minimum of right will be first element of this, and by first I mean a I. Okay, and here it should be b, my bad. Okay, so we got minimum of right in these two cases. Otherwise, the obvious case, the a part of edge case, I know that minimum of right will be minimum of ai, okay, and bj. Simple. After this I will get min r. Okay, if I calculated min r, this means I am to return the mean of these two. So I'll just return mean. See, these two are integers, so I'll divide it with 2.0, because when I am doing some operation with integer and float, so result will be float. So mxl, maximum of left, plus mnr, minimum of right, taking the mean and returning it. So let's run the code. It's some error. Oh shit, I'm just doing everything this way. Nums1, nums2, nums2, nums1, nums, sorry, if I am just, okay, so it should be nums2, then here it should be nums1. Oh my god, this is pity. Nums1, nums2, then I got this. Okay, here it is nums2, nums1, nums1, nums2, and yeah, so let's run this. I wrote num1 here. Such petty mistakes. Known void function does not return a value. Okay, so let's take the case that then just return -1 because not found. Just confirming this is out of the while loop. Yes, it is. If I test it now, accepted. And so I hope you got this solution. Thank you so much for this video. Make sure to subscribe, like, and share this video with your friends.